thank you all for coming. I'm glad you made it. This weather is not something we usually get here, and it just happens to have been arrived just in time for this event. But you're here, at least those of you who aren't here, obviously. But my sympathy to them. But it's good to have you here, and next 3 days are going to be amazing. I'm really looking forward to it. A word about me. My name is Tom Olson. I'm an armed distinguished engineer, which is a nice way of saying that I'm kind of old. And I am also the chair of the Vulkan Working Group since its founding. And then before that, for 8 years, I was chair of OpenGLES, from which you can infer that I'm really strangely, perversely attracted to committees. So let's see, do we have? Right. So this is supposed to be the Vulkan update. But since A, I'm kind of old, and B, this is the first talk of the session, I thought I would go a little bit keynote-y on you and share some personal observations before I dive into the sort of bread and butter of what are the latest extensions and all the usual keynote stuff, update stuff. So my first personal thought is, as I said, it's great to be here. It's amazing, and I'm glad you're all here. My second thought is, I am so glad that I don't have to start this talk with this slide. I've used a variation on this in practically every talk I give for 7, 8 years, and I am so sick of it. So if you did need this, read it now, because it's not coming back and I'm not going to talk about it. My third thought is, why don't I need that slide? And it's because, well, maybe, I mean, I'm a Scandinavian, I'm a pessimist, but maybe Vulkan is growing up a little bit, which would be nice. We're certainly a different operation from what we were even 5 years ago, let alone when we started. The working group itself has a budget of a little over $1 million a year. That means we are 1/3 the size of the average McDonald's. So it's not that impressive in terms of what Khronos spends, but the leverage comes from our partners and the members, Google, Valve, all the member companies who invest orders of magnitude more money than Khronos is able to invest. So it's become a pretty big operation. This is, again, 3 times what it was 5 years ago. We have about 40 people who regularly attend our development calls. We have 10 elected officers, 5 or 6 side meetings. They don't all meet every week, but the main meeting has 40 people in it. And there's a completely separate maintenance meeting, which just handles spec bugs, which is another 30 or so. We have fairly formal, well-defined workflows for how we create specs, validate them, QA them, get them out. We are a lot more mature than we were, again, even a few years ago. And the reason for all this is that if you look at the SDK download statistics, which Karen very kindly provides me every so often, it's very clear that there are tens of thousands, maybe quite a few tens of thousands of people developing with Vulkan every day, building commercial applications that they are depending on Vulkan working and being a good platform, to return on their investment and keep them in business. So a lot of people are depending on the working group and the larger ecosystem to get things right, to not screw it up. We take that very seriously. We accept the challenge. We do not take it lightly. We are doing everything we can to make Vulkan great. The most important thing we need for that is input from people who use it. So things that are not working for you, you can tell us what you need or what you think you need, and we will listen to you very seriously. We really want to know what's not working, because sometimes we have constraints and the thing you would like us to do can't be done because of other reasons. But if you tell us what's not working, we can rub all of those together and discuss with you and hopefully come up with a solution. And certainly we do have plenty of challenges. Number one, in my mind, and I think the working group's mind, when we think strategically about Vulkan, is the problem of fragmentation, the differences between implementations, different capabilities, et cetera. I'll say more about the technical details of that in a bit. But this is the big strategic issue for us. It drives a lot of our strategic initiatives, particularly including profiles and the Vulkan roadmap, which I'll be talking about a good bit today. That's problem one. Problem two, I won't say much more about, but I wanted to say it. High-level language ecosystem is something that keeps me awake at night. Vulkan is defined in terms of SPIR-V. That's what the API accepts. You can't give it a high-level language program, but you have to generate the SPIR-V somehow. So in theory, the working group doesn't care about high-level languages, but in practice, we have to. We have to write conformance tests, if nothing else. But we need developers to be able to use Vulkan. And if, to the extent that the high-level language ecosystem is broken, it's our problem. Obvious issues, a significant fraction, Karen will probably talk more about this, a significant fraction of the ecosystem uses GLSL, that's their thing, conformance test uses it. A significant fraction uses HLSL only, that's their thing. And that's obviously an inefficiency of sorts. It's a maintenance problem for us. So we are working on this, we are thinking about it, we are constantly talking to Microsoft and our members. I don't think we've got it solved. I'm saying this partly to tell you, I am so thrilled that there are so many talks here coming from outside Khronos that are about high-level languages for Vulkan, because that gives me hope. This is a problem we haven't figured out how to solve, but we can hope that there's energy going into it and better things will happen. So that's really all I have in the way of keynote stuff. Sorry, if you wanted more than that, you should have asked Tim Sweeney. So outline for my talk, my thoughts about Vulkan today, that's kind of, you just heard it. I'm going to go next into a sort of quasi-strategic, or at least strategy relevant discussion of profiles and the roadmap. And then the rest of the talk will be the standard update, which is kind of what has happened recently, particularly including Roadmap 2024, which came out 2 weeks ago. So this is possibly at the risk of irritating people who were at SIGGRAPH or saw the talk I gave at SIGGRAPH, because it's pretty much the same thing. I went on a rant about profiles. I said earlier, I thought fragmentation was problem one, and this is tool one that we have for dealing with it. I think profiles are truly awesome, and I feel like they don't get enough respect or enough attention. Maybe we don't talk about it enough. So I'm going to talk about it a lot. And so this is why I think profiles are awesome, and you should pay a lot of attention to them. So Vulkan, no surprise. Everybody here is a Vulkan developer to some degree, right? Yes? Anybody not? Okay, one or two. All right, fine, you're welcome. We are glad to have you here. So those of you who are programmers know that Vulkan is slightly CAPS intensive. The differences between two implementations extend to, could be different core versions. They almost certainly have different sets of extensions that they support. There are optional features in the core versions. There are optional features in the extensions. There's whether you support the extensions. There are things like, what pixel formats can you use? What uses can you make? Can you render to them? Can you sample from them? Can you use them as storage images, etc.? So when your program starts out, it issues this blizzard of queries, and it gets back a blizzard of information telling you, for this particular implementation that you're running on now, here are the things that are in the spec that you can actually use, and the rest you cannot. And you have to figure out how to deal with that, or rather your application does, which is fun code to write, as you all know. So as I said, fun to write that code, and very hard to write an application that will run across a lot of implementations. To some extent, we can't avoid this. Vulkan runs on devices from this big to servers and giant workstations in between with, multi-card GPUs that have their own power supplies. It's, you cannot expect the same feature set across that range of devices. The good news is that the feature set isn't random. It isn't that every implementation is just perversely different. They are subject to different constraints. Watches are being sold into the watch market, or the chips that are in here are being sold into a certain class of devices. Phone chips are, there are islands of semi-coherence, but that coherence isn't good enough, could be better. And so this leads to the idea of profiles. What we want to do is establish sort of and codify those islands of coherence and encourage them to be more coherent within the market spaces that they're attacking. That's what profiles is for. So what a profile is, sorry if you already knew, it's a formal specification of a minimum set of capabilities across some class of applications, of implementations. You can take any set of implementations and sort of automatically, mechanically construct a profile which they all satisfy. It might be they all support at least Vulkan 1.0 full stop, but you can always do it for any set of implementations. And if you take, say, the set that are in high-end cell phones, you'll get something much more interesting that characterizes kind of the inner core of capabilities that every high-end cell phone supports. And that is kind of useful stuff to know. As I said, it's minimum capabilities. The implementation can support, any given implementation may, well, almost certainly does support more. But if, as far as the profile is concerned, if you satisfy everything it requires, you're good. You support that profile. Profiles are not part of the API. They're not part of Vulkan. They're outside it. The spec knows about the roadmap, but it doesn't know about profiles per se. There are no entry points you can call, nothing you can query using, directly to say what profiles do you support. What that means, which is kind of cruel, it turns out, is that once I have a profile spec, it works and it applies to all of the implementations that have the required features. They don't have to know that they support that profile. I can still use it as long as I have appropriate tooling. This is what they look like. We specify them as JSON files, but of course that's just a formalism. This makes them human readable, but of course the exciting part is they're also machine readable. And that creates all sorts of interesting possibilities to do code gen, to do processing, you can take the intersection and union of profiles. You can do all sorts of operations on them. The last talk today, Christoph Rietkio of LunarG, who knows more about profiles, Vulkan profiles, than anybody else in the world, will be giving a talk about them, and you'll learn more about that. Christoph created the JSON schema, he did the tooling, and he's still the lead developer for that. So I'm looking forward to that talk. I said profiles are awesome. They actually sound sort of trivial, right? Very simple. So why do I think they're awesome? One reason is, compared to a core spec, it's like, if I have a profile that does what I want, it's like my own personal core spec. I even can write my own profile that says, this is what I need. I'm Epic Games. This is what you need to run Unreal 5. Epic could do that. They haven't, as far as I know. But it's like writing your own core spec if you write your own profile. Of course, it won't be necessarily on all the devices you want it to be on, but that's a separate problem. But a profile that satisfies you has all the extensions you want. It has all the capabilities you need. That's really nice. Another thing is that in general, in the abstract at least, you don't have to update the driver on the device in order to use it. As I said, it just says you support this profile if you have these extensions, capabilities, features, blah. And so that means that you can come in with a new profile that describes old devices. You don't have to change your code. If you actually try to use a new core version of Vulkan, we've promoted a bunch of extensions, which means we've changed the names of the enums and the entry points. We've done our best to alias them, and we try to make it nice for you. But it's still the case that your code kind of has to change. And of course, you actually never do that because you know that it's going to take a while for the new core version driver to get propagated through the ecosystem. So you code to the old version and use the extensions and alias everything. It's kind of, what's the point? To use a new profile, all you have to do if you want to use it is query, is this, using our tooling, is this profile supported? If it is, please create me a device. Thank you very much. Or please, well, I'm not going to go into too much detail, but it's pretty awesome. So to choose a concrete example, if you code for Android, let's say hypothetically you're trying to reach devices up to 4 years old, and there are maybe a dozen different GPUs that you consider it important to be able to run on, and they come from 4 different vendors, and they all have different caps and blah. You have a kind of an unpleasant problem. But suppose Google says, here's a profile. If you target this profile, if you color within these lines, you will be able to run on modulo bugs. There are other issues, but you'll be able to run on 90% of the devices that hit the Play Store in the last month. That's pretty cool. That's powerful. And of course, actually they already have, there are these roadmap profiles that, Android baseline profiles, which describe a population of devices already in the field. And for 2021, the last time I looked at the numbers, about 90% of the Vulkan capable devices in the field support baseline 2021. I don't have current numbers because I asked for them too late. Google wasn't able to give them to me on short notice. Sorry about that. So these numbers are a year old. We're well over 90% now on that. So that's my rant on profiles and why they're awesome. I hope you're convinced. If not, come talk to me after. One slide on roadmaps. You can tell this slide was not created by me because it has style, it has design. That's because Khronos has an awesome marketing officer, Tim Lewis, who created the slide. He's around, so I can't find it. But thank you, Tim. So just a word about roadmaps. Our messaging has not been real clear on the difference between profiles, which are kind of a tool, they're an encoding, and roadmaps. The roadmap is not, we ship roadmap 2022 and 24. We ship profiles that describe them, but they are not profiles themselves. They're more abstract than that. So the way it's worked historically, can I point to things? I don't have a pointer, do I? Do I have any way to get my cursor over there? I missed it. There it is, yay, okay. Right, so for the first 6 years of Vulkan, what we did was we focused on creating extensions, and every 2 years, we took the extensions that seemed to us to be mature and that we wanted everyone to use, and we put them in a core version, and we shipped it. And for the first several years, frequently we shipped them with a lot of, at least up to 1.2, with a lot of optional features. So the core would say, descriptor indexing, but query all these caps because you might actually have none. And so that partly is part of what got us into the fragmentation mess that we're in, or that we're trying to get ourselves out of now. With 1.3, we said, okay, clearly this business of putting lots of optional features in core is not working. Let's absolutely minimize that. So in version 1.3, you have almost no optional features. So, we only do it pragmatically when we need to. But what that meant was the feature set of 1.3 was not very impressive. And we wanted to express the fact that the sort of average device in this time frame is much more capable than that. So we also created, the mouse is there, it just moves real laggy, so it's hard to find. So we created Roadmap 2022, which characterized not every Vulkan implementation, but the set of Vulkan implementations that we call the immersive graphics market. So that includes medium and high-end smartphones, laptops, tablets, some consoles, desktops for sure. And another way to say it is it characterizes the devices that support a lively third-party software market that have open, ability to purchase and install content after you've purchased the device. And so Roadmap 2022 back then expressed what we thought a device in those categories would have, at least a new device, starting in mid-22 and propagating through the ecosystem as fast as it could. Because as new thing comes out, desktop is going to pick it up next week or next month because you can download and install a new driver. But a laptop, maybe a year if you're lucky, and a mobile device, you may never see an update. So it takes different lead times to get these things in. But 2022 is the roadmap milestone tells you we expect to be in every device in this category at some point and starting now. And then we have just done 2024, as I said last week, a new one, which I'll talk about later. These will feed into new core versions eventually. There'll be subsets, probably won't be the whole feature set of the roadmap node. But as I said, the core is, I'm trying to get you to believe, cores are not that interesting anymore, unless you're in the watch space or the refrigerator space or some very constrained space. And the roadmap is really where it's at as far as the technology evolution. Okay, that's the end. How am I doing on time? Maybe I'm okay. That's the end of my sort of rant and strategic thinking. Now I want to talk about what is actually new. And of course, as I've said several times, the first thing that's new is the Roadmap 24 milestone, which we released week before last. This is our second milestone. Again, it's expressed as a profile because it's very concrete. We know exactly what's in it, and we can express it as a profile. Excuse me. It is a little different from some profiles. It's forward-looking. It has extensions in it, which we released at the same time as the profile. So what I said before about, you can start using it immediately on any device that supports it, well, you're going to need a driver update to support Roadmap 2024 because some of the extensions in it are brand new. NVIDIA beta drivers already support it. RADV is this close, I think. Last time I heard, I think AMD is very close. The commitment we make to you is that all of us, like ARM's a GPU vendor, we will have products ready that support this by the end of the year. But for us, what that means is we'll deliver them to the people who make chips using our silicon IP. So how long will it take for them to reach the consumer? It's going to be a while, as fast as we can make it. But all of us who are members of Khronos are trying to commit that we will deliver this set of features as a coherent package that you can target as quickly as we can, which is pretty much all a core version ever meant. So it kind of has the same semantics as a core. So as I said, a profile or a roadmap milestone is a characterization of a class of devices. It's a minimum set of capabilities. So what the roadmap node requires, one of the most exciting and yet not glamorous things is you can have almost twice as many descriptor sets. You're guaranteed to have almost twice as many color attachment or color attachments as you used to in older versions. So that's nice. There's a bunch of required features that were optional from previous versions of Vulkan. You're guaranteed to have multi-draw and direct, to be able to get the draw parameters in a shader, to be able to do nice gathers. I think very exciting because I like writing little kernels of code. You can have legitimate int 8, int 16, float 16. You can store 8-bit quantities and 16-bit quantities, and you can turn on round to nearest even if you want it. There's also a bunch of older extensions that we've made mandatory that must be supported. You still have to turn them on, but to satisfy the profile, you have to allow turning them on. Push descriptor, I think everybody knows. Uniform control flow is a technical amendment relating to how subgroups behave. Map memory 2 just makes memory mapping extensible. Maintenance 5. Everybody loves maintenance extensions, I'm sure. Maintenance extensions we do when we have a feature that is so small that an extension to add it would be incredibly annoying. So what we do is we just sort of batch them up, and you get this grab bag. And if you hate them now, you're going to hate them more soon, because we're going to do more of them. We've discovered that when we did maintenance 5, it had a lot of stuff in it. Took us a long time, was very painful to build. So we've gone to rolling releases. We're trying to do a maintenance extension every 6 months. Maintenance 6 is already here. We're working on maintenance 7, and we're working on maintenance 8 in parallel. So just suck them up, turn them on. If they're there, you know, you can grep for the string in the extension. You always want them. Other extensions, there's a bunch of things that were EXTs that we have promoted to KHR and required. Why did we promote them? Seems annoying. Well, mostly for marketing consistency. Our message to you with the KHR extension is, this is the future. It's the highest quality extension we can produce. And our message with the roadmap is the same. This is the future. This is what you should be using. So it didn't make sense to us to have an extension be required in the roadmap that was not labeled clearly as, this is the best. This is what you should use. So we promoted a bunch of these. In every case except Vertex Attribute Divisor, it's a straight promote, no changes. You can ignore, you can alias. It is in fact an alias of the old EXT extension. In Vertex Attribute Divisor, it turns out that there was a difference between mobile and desktop devices, and because the mobile version of instancing did not allow first instance to be non-zero. I don't think it even had first instance. It was implicitly 0. I could be wrong about that. So there's a flag in the KHR which tells you whether first instance can be non-zero. Sorry about that. Then there are some new extensions in Roadmap 2024, not a lot of them, but a few. And I'm sort of doing them in, starting with, I don't want to say boring, but less exciting to more exciting. So shader expect assume. This is kind of a parody with OpenCL thing, because OpenCL's had this forever. But this is a way for you to hint to the compiler things that it can use to generate better code. Like if you have an if statement, if extremely rare error condition, then do this, otherwise do that. Well, it's useful for the compiler to know that the if condition is almost always false. It can generate better code if it knows that. So this allows you to tell it that. You can tell it things like, this loop has a dynamic bound, but it's almost always less than 8. And the compiler may be able to use that to make unrolling decisions or things like that. So it's there, don't have to use it. I think it may not actually be exposed in GLSL. Sorry about that. That will come. But anyway, so that's there. Shader subgroup rotate, it's an optimized permute. A rotate is just like a circular shift within a subgroup. Each of us hands data to one neighbor and receives data from another neighbor. And it's a special case of shuffle operations, which we already had. but there are implementations that have optimized versions, optimized paths for rotate because it's common. And so we don't, this saves the compiler from having to try to reverse engineer your shuffle instruction to see if it's actually a circular shift and use the optimized path. And finally, float controls 2, again, parity with OpenCL. Float controls in Vulkan now work exactly the same, I believe. Graham, Lease, tell me if I'm wrong, but exactly the same as in OpenCL. And what's nice about it is it's much finer grained. The old float controls extension, you put your float controls on the entry point, and it applied to everything within that entry point, which was kind of terrible. And so the new thing, is per instruction, and it also applies to many more instructions than the old float controls thing did. There's lots of details. If-nan behavior is still a nightmare, but anyway, it's a nice advance. Maximal reconvergence, probably the most important extension you've never heard of and will hardly ever think about, and that's by design. I shamelessly stole this slide from Alan Baker's completely awesome blog about maximal reconvergence and shader quad control and why you should care. And just to, I have time for this. Where is my? Yeah, I'm going to have to stop using but I have to be able to point to these things. There it is, yay. So y'all know GPUs these days are SIMD or warp-based. You have a whole bunch of invocations executing in lockstep. They each execute the same instruction. So that top bar there, you can see that's a whole bunch of active invocations. They're all executing the same instruction. They come to an if test on a non-uniform, meaning the value is different for each invocation, on a non-uniform condition. And what happens is some of them, it turns out to be true, and others, it turns out to be false. And so what happens is the ones where it's false get turned off temporarily. They don't execute those instructions. The ones where it's true keep executing the whoops. How did that happen? Keep executing. And so they do the then part of the instruction. Sorry. Right, so these guys are now active, the green guys. Suppose they now then do another test with another non-uniform condition. Again, some of the green guys are now stay active and some of the green guys get turned off temporarily. And they execute the then code. And then the guys who were active turn off and the guys who were inactive turn back on and they execute the then clause. And then you fall out of that block and you're back in the top level if. And you would think that if you then do some kind of subgroup operation, such as a vote, that all of those invocations would participate in it, but it's not the case. The Vulkan execution model does not guarantee that by default. And this can lead to incredibly obscure and frustrating bugs because it just defies intuition. So you can do what you want. I'm not going to try to figure it out. I just believe Alan, he told me it's true. And so I know that if I want to get that natural intuitive behavior, I have to turn on max reconvergence. That's what this extension gives you, is that subgroups now work the way you thought they did. And so cool. Like I said, it's the coolest, most powerful extension you will hardly ever think about and probably don't need to know much about. Although if you do, more power to you. Alan has an awesome blog. These slides will all be posted. Go read his blog for a lot more on this topic. Oh, and shader quad control, much more niche, where max reconvergence is huge and has far-reaching implications. Shader quad control uses it. It's a niche instruction about the quads that participate in computing derivatives and level of detail selection when you're sampling from textures. And it turns out that they also had problems related to the loosely defined nature of convergence. And with max reconvergence and shader quad control, you can now guarantee yourself nicely behaved derivatives and nicely behaved LOD selection. The other big one, particularly exciting to me because I'm a mobile guy, dynamic rendering local read. The formal definition is a little obscure. It allows pipeline barriers within dynamic rendering with self-dependencies, provided you include the dependency by region bit, which basically means what it boils down to is under appropriate circumstances, a fragment shader arriving at a point can sample from the data left there by a previous fragment. That can be true in the color attachment. It can also be true in storage accesses, storage rights made by that. Again, as long as they are by region, which in practice pretty much means a fragment at ij in the frame buffer can read stuff left by previous fragments at ij in the frame buffer. And so that's cool. Two things are cool about it. One is it works on desktop. It has performance implications. You'll need to be careful with it, but it applies universally and it's in the roadmap. Everybody's going to support this. So that's cool. The other thing that's cool is that if you're on mobile and you have been using things like frame buffer fetch or pixel local storage to do things like deferred shading, where you need to be able to read from the frame buffer, you can now do that. You need another extension called rasterization order attachment access in order to do everything. So those won't probably work on desktop unless they decide to support that extension, which, well, I hope they do, but not likely. This is a complex topic and I'm barely grazing the surface to really understand it. The first blog is by the author of Dynamic Rendering Local Read, and it gives you quite a bit about a desktop perspective on it. The other blog, which I've quoted here, is from Jan-Harald Fredriksson at ARM and explains a mobile perspective on how, in what sense, this is equivalent to the functionality we know and love and lets you do things like programmable blending, et cetera, on tile-based architectures. There's a bunch more extensions that have been released. This is looking back 1 year because it seemed like a reasonable bound. I'm going to talk about some of these, but not all of them. I'm showing you the list just because I didn't want you to think we've been goofing off entirely all year. So now we're going into a reasonably long list of what we have done in the past year, starting with Vulkan Video. So maintenance one is just video's new, you make some mistakes, just as we made some mistakes with early Vulkan. And so there's some cleanup and some fix up in maintenance one. If it's there, turn it on, it's good. More exciting perhaps, the video decode stack went final last year, having been provisional before that. Now the encode stack has also gone from a provisional extension, which means we do not recommend you use this in production code, by the way, but it's now final, which means we do recommend you use it in production code where it is supported. And so along the encode stack consists of encode Q, which is kind of framework stuff, rides, there is also, right. And then we have to prove it out, to prove that it works, 2 codec extensions, encode H.264 and encode H.265. And very exciting, as of last week, only 5 days old, video decode AV1, which the community has been eagerly awaiting, and we're very excited to finally have it. We're very grateful to the open source community, particularly a lot of people involved with FFmpeg and other frameworks have helped us get there, joining the working group and putting their shoulders to the wheel. So that is now out. Decode only, but hold that thought. So this is the picture today. The video stack is very complex. There's a lot of extensions that kind of fit together like a puzzle. The reason for that is so you can ship a device that is, for example, only a player, because you might have a consumer device that only does video playback and doesn't need to encode. Or you might have a camera, which only needs to encode and doesn't need to playback. That seems a little unlikely, but could happen. So anyway, the system is, the extensions are architected to allow that. So what we have today, as I said, we have 3 decoders and 2 encoders. AV1, so we have this thing, a paranoid fear within the working group of promising stuff that we haven't delivered yet, because, you know, if you disappoint people, they get really mad. But AV1 is really close. That is, AV1 encode is really close. So I'm not going to give you a date, but it is very close to here. Second priority for the video group, it's a separate group within the working group that does this. Quantization map and adaptive quantization. I will not embarrass myself by trying to explain what those are. I have a guess, but it's probably wrong. And so those are also under advanced development and on their way out. In the wings, VP9 decode will be the next big thing that comes out of that group. Exciting to me, you know, and I really have to congratulate the group. They've done all this work. They've been working for years, and Vulkan Video is now a thing. It is supported in mainline FFmpeg. I'm going to say these things and I hope they're true, but I believe they are true. I believe it has landed in GStreamer. That is, the merge request has been signed off. I don't think it's actually shipped in a release version, but so both of those, and the GStreamer version is not on top of the FFmpeg. It's a native version, is my understanding. And that means that it's being used in real applications like MPV, which uses FFmpeg. So Vulkan Video is really, truly a thing. Keeping track of that status of adoption is so complicated that Victor Jaquez at Igalia is now keeping a live blog in which he records the status of uptake of Vulkan Video in various places. So that's a good thing. And we're fortunate to have Tony Zlatinsky of NVIDIA. I don't know if he's here yet, but he will be talking tomorrow about Vulkan Video. He's one of the lead developers within the working group, has done amazing work, and knows, as I said, far more about it than I do. We'll talk about it. There are other people also talking about using it. I believe people from FFmpeg or GStreamer or both will be talking about it. And again, thrilled to have them here. In Vulkan ray tracing, only one extension, but it is the big one, ray tracing position fetch. And what this does is allow you in the shader to cheaply and easily access the positions of the vertices for the triangle that you hit. This was, as far as I know, motivated first and foremost by a problem that Yuri O'Donnell at Epic ran into trying to implement Lumen and trying to use hardware ray tracing in Lumen. And Lumen, it turns out, needs to know the geometric normal. An array hits a triangle, it needs to know the geometric normal of that triangle. Now, you know, traditional old school, before this extension, you could still do that, but it was relatively painful. It took a lot of work. If you look at, so this again is from the blog that Yuri and Daniel Koch of NVIDIA wrote to explain why you needed this. So on the left here, I hope you can read this code. This is what you have to do if you don't have this extension. The shader is going to be given a primitive ID, and then you, the programmer, have to make sure it knows where the index buffer is and where the first index is within that. And then you have to go and fetch the indices of the 3 vertices that participate in the triangle. And then once you've got those indices, you have to go down here and fetch the actual vertex positions, 3 vertices, and then you take the cross product and you got your normal. And that's fine, but look at that. You've got 6 reads and 3 of them are dependent. That is a horrible thing to do to a GPU, and it's very expensive. So now with this extension, it's a built-in, you can just read it. So that's much nicer. Isn't to say it's free, because the implementation is going to have to give you that data, and it may have to do work. But the information about where those vertices are is implicit in the acceleration structure. So the driver knows. It's just a matter of, to support this extension well, they may have to be a little clever. But anyway, this is a really nice win. The blog is really cool, and the performance win for Lumen on this was pretty spectacular. While I'm talking about ray tracing, I'd be remiss if I didn't say ray tracing on desktop, of course, has been around long enough that it's kind of no longer news when somebody does something cool. And I'm glad to see it. I'm thrilled that people are using it, but it doesn't sort of surprise me. But what has surprised me this year is that ray tracing is beginning to be a thing in mobile. There have been mobile demos for years, but they were kind of toys. Some of them were software implementations. They were kind of like, when people build a microprocessor in Minecraft. It's not that it's really that useful, but it's really impressive that you can even do it at all. And that's where ray tracing was on mobile until quite recently. But in the past year, there are devices coming out where ray tracing in a mobile device actually has enough power to be good for something. Throughput is still orders of magnitude less than you will get on a sophisticated desktop device, and that's probably going to be true. It's going to be true, full stop, for a long time. Also the case that it really only shows up in premium devices, and you have to ask yourself, does that constitute a market? Well, for some people it is, for some people it isn't, but it is coming. Iago, one of my colleagues from ARM, will be talking Wednesday morning about, because you have so much less throughput, you have to think differently about ray tracing from the way you would on the desktop, and he'll be talking about that. A little bit of platform news. So Vulkan on macOS and iOS is, something. It's an ambition. We want to rule the world in the Vulkan Working Group. We want to take over everything. We want to be your API of choice everywhere. We know that's not achievable, but it's not going to stop us from trying. So we want to run on macOS and iOS. And we have the problem that you cannot install drivers, even if it wasn't a proprietary GPU, which on some Apple devices, they have discrete GPUs. Still, Apple won't let you install a driver. So there's going to be no native drivers on Apple devices as into the foreseeable future. So what you do, of course, is emulate. So quite a few years ago, Bill Hollings of Brenwell created this thing called Molten VK. It's a shim library. You link it with your application. You call Vulkan. The shim library translates it to Metal, which is the native graphics API. The shaders get translated from SpearV to MSL when you create the shader. And it all works great, except that there are a few capabilities that Vulkan requires that Metal doesn't have. So Molten VK is not a conformant implementation, but we've done our best to formalize what it is. So it's not like, oh, it might or might not do this. It's very well defined what Molten VK supports. It's a concrete subset of macOS, sorry, of Vulkan. Status of this, LunarG SDK works great on it. Karen may say more about this, but I believe all the tools work. Debug layers and validation layers work. It is currently at the Vulkan 1.2 subset, and it is 5 extensions short of Vulkan 1.3. Again, a subset, but everything that that Metal supports that is in Vulkan 1.3 only needs 5 more extensions to have that fully. And working on conformance, there are places where the conformance test for the subset doesn't pass, but they are things you will typically not hit if you're a programmer. They're kind of corner cases. So in consequence, there is a lot of content shipping using Molten VK. this includes a lot of commercially important and significant applications, a ton of games, but also things, I find the Autodesk stuff really awesome, that you can run that on a Mac OS device. And I think that's all I'm going to say about that. Oh, except that Bill Hollings is here. He will be speaking about the status of Molten VK this afternoon. Android, again, sorry, I am stuck on data that is now a year old. But a year ago, there was some version of Vulkan on 85% of devices, and the curve over time, which I have been tracking, is as linear as any curve I've ever seen in nature. So I think we can safely extrapolate to where we're well over 90% now. Frankly, Vulkan 1.0 devices that are still in the field, I would be cautious about targeting, because those early implementations were buggy, including mine, ours, but all of them were pretty questionable. So I would mostly stick to 1.1, but we are probably getting pretty close to 90% on 1.1 as well. I don't know, oh, and of those, as I said, about 90% of those devices support the baseline 2021 profile. Ian Elliott from the Android team is here and will be giving us a more serious status update on Wednesday morning. I wouldn't be a Tom Olson talk if I didn't talk about conformance testing. As I said, we were painfully aware that early Vulkan implementations were not of the quality that developers needed them to be. This is the number of directed tests in the conformance test suite through last summer. We're we're slightly over 4 million directed tests right now, and we have 4 contract engineers working full-time on adding stuff. So the conformance test, plus we working group members add tests as well. When we write a new extension, very often it's the extension author or someone they designate who writes the initial conformance test, and certainly the test plan for it. So this huge spike at the end, by the way, was caused by the shader object extension, which added a blizzard of new cases that all had to be exercised. So that's why you have that huge leap. It's causing some problems. The test is big now. We're probably going to have to start factoring it. Writing the test log is starting to be a problem on mobile devices. We're going to have to be refactoring, but we have staff to do that. We have a budget. It is, I said, we spend $1.25 million a year. More than half of that is conformance testing. SDK and tools news. I'm not going to say anything because we have Karen. You're not up yet, Karen, but thank you. Karen is CEO of LunarG, and they are the people who do all the heavy lifting on the SDK and build many of the tools that are included in it, and import the others and qualify them and test them together and do a whole bunch of stuff that makes it a robust tool. Karen will be talking about that immediately after me. And hey, I'm kind of on time here. We have, again, things we didn't have 5 years ago. We have DevRel. We have Marty, who is an experienced and extremely capable DevRel manager, leader, and also does on the side project management for me so that I don't drop balls, and helps keep our, as I said, we have a formal workflow for creating new extensions. He makes sure that we check the boxes and do the QA and don't ship stuff that's corrupt. So Marty is awesome. And then we also have Tim Lewis, whom I referred to earlier, who is our marketing guy, but because we're a small organization, he's a jack of all trades, and they work together to lead our documentation and developer support operation. I should mention Steve Winston of Holochip. Also, he's our elected documentation officer, and they're working together. And their latest project, if I had more time, I would live demo this, because if you haven't tried it, it's cool. docs.vulkan.org. If you're used to going to, VK, what is it, blah, 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 .vkspec.html to look at the Vulkan spec, that still has its uses, but you want to be using this almost all the time. We did a prototype of this and had it out we did dog fooding and we did a public beta of this, but it's now production. Not to say it isn't a work in progress. There are lots of things that need to be done, and we eagerly solicit your issues raised on the Vulkan site repository. But this gives you, like I was using this to put this talk together to find all the information about these new extensions. So it gives you seamless access to not only the spec language about a given feature, but also the proposal document. If you didn't know about proposal documents, start looking at them, because they are kind of the rationale behind an extension. The extension just tells you what it is. The proposal document tells you why, and that is powerful information. This thing will find you that just as easily as it finds you the spec language itself. The state of linkage to samples, because we have Vulkan samples, they're in this, but I'm not sure that searches take you, do they?
Yes, they do.
Yes, they do. Okay. So if
Here
there's
we
a
go.
sample code that uses an extension that you're curious about, again, this will find you. You get a rather long menu and you have to scroll through it. Like here are the hits in the spec. Here are the hits in the samples. But right, here's the hits in the Vulkan guide. Also, the Vulkan guide, which was kind of moribund for a while, is alive again. And we're spending money. We have a contract out again to Holochip to improve it and build it out and make it more awesome. So this is all happening. The HTML build of the spec, we may eventually deprecate. We'll keep it as long as you need it. But we think this is the way we want people to access the spec. If it isn't working for you, please tell us ASAP. I was going to compile a list of recent articles in the Vulkan guide, and I didn't get quite around to it, but I did want to mention, because I said high-level language is a big issue. One of the historic problems has been using HLSL, finding out how to use HLSL with Vulkan. There is a guide entry on it, which is pretty good, and there is a merge request on the Vulkan site right now for another chapter written by Sasha Willems, famous developer of Vulkan samples and an active participant in the samples group and a member of the working group as well, by virtue of how important he is to the ecosystem. Sasha has written a chapter that basically gives you a tabular mapping of features between HLSL and GLSL. So if you know one and you need to know how to use the other, this will give you the kind of the correspondence table. And so that's pretty awesome.
One other thing, I'll just interject real quick. We've also been working with Alexander Overbrood from the Vulkan tutorial site,
Sorry,
and we've imported that into the spec
right,
site as well.
The Vulkan tutorial is also accessible. So speaking of samples, samples project 3 years old, 4 years old?
Well, I've been here for 3, so I think it's about
Okay,
about
right.
three.
Marty is the guy who really took it and ran with it. So the world is full of Vulkan samples, or the internet is full of Vulkan sample code, but the problem with it is you don't know which ones are good. Typically, if I'm a student or even if I'm a professional programmer and I write a Vulkan sample, I test it on the hardware I have and I ship it. And that means that if you go download somebody's sample and you're on a different card, or God forbid you're on a mobile device, is it going to run? You know, it's almost not worth finding out because the odds are not good enough. We wanted to fix that problem. So Marty and a number of other public-spirited members of the working group took this on years ago to say, let's have a Khronos curated samples repository. And we took this very much as we are humbly coming to the community of sample developers. We're not telling you how to do things. We're asking you, please participate. Can you help us? Can we help you make your samples more awesome? So within the samples group now, we have the participation of a number of outside developers, notably Sasha Willems, but also others, who contribute their samples, and we test them on multiple devices. We try to make them fully portable. We can't guarantee it, but it's better than it would be if we weren't doing this. We try to make them platform neutral, so they use a framework which will be, which allows you to, it doesn't have to be Windows. We try to isolate you from that stuff as best we can. All open source under Apache 2, and you can go to docs.vulkan.org and read about them, or you can go straight to the GitHub repository, Vulkan samples. Again, I want to stress, we don't control this. It's a community enterprise. And I'm very proud of that. I think that's the way I want it to be, and I want it to be more so.
A quick time check to Tom, you're getting close to out of time.
I know. There are a bunch of new samples. I wanted to highlight a few. We have historically done there's a lot of samples which are, here's how to build a map chain in Vulkan, because Vulkan doesn't do it for you. So simple kind of basics, but there are also some which are kind of advanced techniques, and I would highlight these three, which I think are pretty cool. Sparse images, virtual texturing is cool. I'm a sucker for OIT, especially hair rendering. It's like my hobby. If I actually wrote code, but it's my hobby to read about it. And then Qualcomm has this cool demo of mobile nerf, which reminds me, machine learning is going to be a thing in mobile in Vulkan too. But I won't say more about that now because I'm almost out of time. Last slide. And among other efforts that Tim and Marty conduct is Vulkanized. And they did the first one. I will credit Tim, maybe I'm wrong, but I'll credit Tim for being the guy who said, no, seriously, a one-day session in a dingy hotel room is not cool. You need a real conference. And so we tried it last year. Thank you, Google, for hosting that one in Germany. And we had 3 days of sessions, and it was awesome. And so we said, we have to do this again. So here we are, and welcome. And thank you so much again, Google, for hosting. Thank you, everyone, for coming. Thank you, presenters, for preparing your material. This is going to be awesome, and I can't wait for it. I apparently do not have time for questions. Am I on the panel or not?
You are on the panel.
All right.
Yeah, that's probably the best place. You can probably take one or two because we just shortened the break a bit, but we should keep it short if we can.
If you
I'd
like to record them for the video too,
Sure.
so come around with the mic if folks have a question.
So if there's an urgent question, ask it.
You mentioned something about machine learning. Is there any plan for that?
Well, Modulo, our well-known nervousness about talking about things we haven't released. There is one of the subcommittees. We have 6 or 7 technical subcommittees. Ray tracing, for example, one of them is machine learning, and they are working actively. It's a hard problem. We have released some kind of small things. There's a recent extension, which I may have been on my list there. I'm blanking on it. It's essentially a reduced precision dot product instruction in SPIR-V. So not incredibly exciting, but bigger things are coming. If you're familiar with the NVIDIA has a cooperative matrix extension. We don't have that yet, do we? Maybe we did release that. It's embarrassing. I'm the chair of the committee and I don't know what we've released.
whether it's released yet.
Yeah, cooperative matrix is either here or almost here. And we do have this dot product instruction. Bigger things are coming. And, as you know, everybody in this room is in the machine learning business to some degree now, because that's how the technology industry works. And we are too. But I don't want to say more than that.
Thank you.